second lesson, motion in a straight line. So in this lesson, we are talking about the speeds and then uh, the directions of the movement, and we are going to draw different graphs for their movements, like maybe different things in this nature. There may be an animal or a vehicle or something like that. Once it is moving, it is in a motion, it's moving. So in this lesson we are talking about the movements, those which are on a straight line. Then here in this part you can see a girl is walking with a particular speed, but it's slowly, and a bird is running very fast, and some bees are moving, they are flying like this, and a car is going in a straight line, and a cat is walking. So in this way there are different movements in our day-to-day life. So we are going to learn about those things in detail. And then in our first part of this lesson, we are going to learn about distance and displacement. So when we are going to learn about the motion, with related to that word motion, the distance is there. Distance is, it's like the length of a path we are going to travel. That means when we are going to the shop, we coming out of our home, and then we come to the gate or the road, and then we are walking to the shop. So different places we are turning to different sides. Maybe we are turning to left side or we are turning to right side. In this way we are going to the shop. So it's just if we take the length of that path, it is named as the distance. It doesn't have a specific direction. Uh, it sometimes we may be facing into the left side. Maybe we are facing into the north side, and then sometimes to the east, sometimes to the southeast or the northwest somewhere. So in this way, the direction is changing. So that is the the smaller example we can take to think about the distance. It doesn't have a direction, and it is just the length of the path traveled. And displacement. Displacement is somewhat different from this distance. In this displacement in this displacement, we have to think about the direction. Now we are not just wandering here and there in by turning into different directions, like to the east, to the north, and again to the northeast. In that way, we are not turning to many directions. We are going just going forward to a particular direction. So it is a straight line. We are walking. If we are walking, we are walking in a straight line without turning. So displacement, the definition for this displacement is the straight line distance between 2 points. And we have some added part along a particular direction. So as we can consider about this distance and displacement like that, we can take this displacement as the shortest distance between 2 points. When we consider about this A and B, this is the distance which is going to be traveled along like this. But if we take a straight line between this A and B, it is the displacement. There's no bends there. And here in this image, there are some mountains and there's a road like this. It is in between the mountains, and roads are like this. They are turning to different sides. So the length of that road is 200 meters. But if we can take an imaginary line between this house and his factory, it is just only 150 20 meters. So that is the shortest distance between these 2 points. So here we can take this 200 meters as the distance or the length of the path and 120 meters as the shortest distance or the straight line distance between these 2 points. It is the displacement. Did you understand that?
Yes, teacher.
Yeah. So I show you a tube. So there is some thing you have to fill. I show it you. Did you check? Have a look on that before the class.
No, teacher.
Yeah, it's fine. Okay, I'll show you. Give me a second. Mm. So this is the tute. You can take a printout of this later. And here there is something you have to fill. Distance, the length of the path travel and specific direction cannot be found. Has only magnitude. That is the word. I am going to tell you about this later because we are discussing it in detail in a next slide. So here you have some diagrams to complete the answers. So I'm taking this first one. Here you can see, uh, what about those things? Can you see this clearly?
Yes, teacher.
Yeah. So then can you tell me, uh, consider about this first image, okay? Here, what are the distances or what are the displacement? If there is, what are the displacement or what is the displacement and what are the distances? Can you differentiate them?
150 meters is the
Yeah,
displacement.
150 meter.
Yeah,
Yeah, it is a distance. Can you see here? It is not a straight line. But what about this 120 meters?
120 meters. Does it belong to the first picture?
Ah, yes, it's belong
Uh,
to the first picture.
okay.
It's not bit clear because they are closer.
Yeah,
Yeah. So, is that the answer?
yeah. 120 meters is the displacement.
Yeah, is the displacement. And what about these two? They are
Distances.
they are distances. There are two paths between these A and B points, but whatever the path between those points, 120-meter path is the shortest distance between those two. So we call it as the displacement. So new friend connected with us, we have to talk with him. Uh, New student, can you tell me your name? Can you hear me? You can unmute and answer. Can you hear us? Can you hear us? Can you hear me? not answering. Can you hear us? Can you hear us clearly?
Yes, teacher.
Yeah, you can. What about the new student? Uh, okay. Not answering. Okay, we will continue. I hope the new student also listening to the lessons.
Yes, teacher.
Yeah, it's fine. Can you tell us your name?
Yes, I'm Aaron Pereira.
Aaron Pereira?
Yes.
Yeah, it's fine. Okay. So we started the lesson. You couldn't join at the beginning, so we were discussing about the distance and displacement. So I'm going to tell you about that again to you. So
Okay.
Aaron, so this is in this section we have to learn what is the distance and displacement separately. So here distance is just the length of the path. There are many distances between 2 points with many different lengths. It's like when we want to go to the school, we have few different pathways. Maybe from one junction and maybe from another rural area, or there may different paths to go to the school. But displacement is somewhat different from that. It is the shortest distance between 2 points. We call it as the straight line distance between 2 points. And another thing which is relevant to this distance and displacement is distance doesn't having a direction. It doesn't have a specific direction, but displacement has a particular direction. Maybe to the west, to the north side, or maybe to the few different degrees angle from one direction to the another. In that way, it is having a direction. In this distance, we have only a magnitude here, but in displacement, we have both magnitude and direction. And then that is the thing I was discussing about, and then I showed the PDF or the tutorial which belong to this lesson. So at the beginning of the class, normally I am sending this to you a day before the class or at the morning of the class day. So you can take a printout. So it is now when you have a PDF printout, you have it as a hard copy. Then you can fill the answers while I am conducting the class. Okay. So since this is the first day, I think that you don't have it with you today.
Yes, teacher.
Yeah. Then I was showing just an example here. So Aaron, here, can you tell me what are the distances or what are the displacement? Just consider about this first question. There are two distances, 120 meters, 150 and 350. What about the differences? What are the displacements or what are the distances? Can you tell me? Can you just tell me?
The displacement is 120 meters. And
Yes,
the
good.
distance is 150 meters and 350 meters.
Yeah, yes, good. there are many distances between 2 points. So there are a few examples, you can answer them. And then here I am moving to the lesson now. So in this, these are few another examples. So this is about again distance and displacement. Here you can see there are two paths. One is 5 km, other one here s is the displacement here. It is just 5 km. But there are two another paths, part 2 and part 1, with the distances which are longer than 5 km. Always the smallest or the shortest distance is the displacement. And here in this example too, there's a displacement and there's another path with a particular distance. Here, there's a way to emphasize this displacement. So that is, we have to tell the length of the path and we have to tell the direction. We have to tell both of them by once we are answering to a question like what is the displacement. So here in this first image, it is 5 km in the direction of 40 degrees from east to the north. Here, this is the east and this is the north. This is north, this is the east. So this boy or whatever, no one is here, but maybe a person here, but he is moving towards here in the direction of 40 degrees and 40 degree angle from east to the north. Did you understand that, both of you?
Yes.
Yes.
Yes,
So,
teacher.
yes, okay. So here also same. There's a 50 degree angle here. And I have to tell the displacement. So here it is distance, the length of the path is 4 km. It is mentioned here, 4 km in 50 degree angle from north to the east. We can tell it here that in the direction of, it's better if we can write it here, in the direction of. Yeah, in this way. And next. That is the normal way to tell the distance and displacement. Now here we have some problems here. There's a starting point and there's an in-between point and there's an end point here. So maybe a person or someone is moving from in this starting point to the direction of the end point. When he or she is moving in this direction, we have two distances mentioned here. So we have to find the displacement or the distance here. In this case, since this is a straight line, we are talking about the straight line distance only. So this is a displacement. It is just 5 plus, 3 plus 2. Yeah, this is 3 plus 2. Total is 5 km. And if someone asks, what is the distance then? So we have the same answer. Displacement is also a distance. But here, there's some mistake with these answers. Can you find what is the mistake here? In displacement or distance, there's a mistake. The way we are telling it. Can you identify? Both are mentioned as 5, but there's a mistake. In distance, we know that it has only a magnitude. But displacement, it has a magnitude, and together with that, it has what?
Direction?
Yeah, it has a direction. So we have to tell it to 5 km to the east or to the right side, to the east here. We have to mention it. That is really, really important. Without mentioning it, we are not giving the displacement. So it's really important. And then I am moving to the next one. So here, since they are in this, before moving that, since those distances are in the same direction, we can add them. Did you see that? We can add them together. So, but once it is in the opposite direction, if we are turning back and coming back, we have to reduce the shortest distance or the movement in the opposite direction from the longest distance to the another direction. Here, look at this. Here it is mentioned as this is the right side and this is the starting point. And this is the end point here. In this case, end point is at the middle. This person here, he has or she has come to this place first and then move to the end point, which is in between both points. So consider this as 5 meters. It is given here. This is the total length is 5 meters. She has coming back 3 meters. 3 meters. So once we are considering about this right direction, we have to take that as the direction of movement. So we have to reduce the value which is in the opposite direction from these 5 meters. So we have to reduce 3 meters from this 5 meters. So our answer is 2 meters here. So that is our answer here. We have to reduce it from 3 to find the displacement, because as the displacement we want the shortest distance. This path is not the shortest distance. She has come here and then has come to here. So this is not the shortest distance, it's just a long path. So this long path is the total distance she has traveled. This is the total displacement she has done here. And once we have asked what is the distance is, we can tell that distance is 8 meters. 5 meters plus 3 meters. 5 to this place and 3 to this place again. So we have to add them together to find the distance. Here in this case also, we are adding both together. Here distance and displacement is same in magnitude, but displacement has the direction. In this case, those are not similar in magnitude. Those are different in magnitude. This displacement is shorter than the distance. So here she has moved in the opposite direction later. We have to reduce that value from the longer distance he has traveled in the particular direction. This is right direction. Did you understand that one?
Yes, teacher.
Yeah. So here in this PDF, you can answer those things. Here it is asked that what are the displacement and distances once we are moving from A, B, C direction. From A to C, here it is A is somewhat, it has moved, it's just a mistake. So A to B and then to C. Again here A to B and to C. So you can find the answer here also A, B, C. Consider about A, B, C when you are answering like that. So here I'm moving here into the next slide. This is another type of question we have to answer in this distance displacement section. Once we are given a right angle triangle like this, we know that Pythagorean theorem. So we can use that to answer this type of questions. Here, Ravi should go to the tree named as C by bicycle. His path is given in red color. His normal path is given in red color. He come to the he first comes to the home, which is named as B, and then he is moving to C. So here, from A to B, there is 4 km. From B to C, there is 3 km. And important thing which is given there is the right angle. So once we are given this type of question, we are not given use this Pythagorean theorem. So we have to identify that by this 90-degree angle or the right angle which is given here. So we can use that. By using that, we can find here at first, what is the distance? This is the question at first. So we can find the distance. How to find the distance here? Can you tell me? One of you or both of you? It's fine. Timandi, at first. How to find the distance?
Maj, you should add 4 kilometers and 3 kilometers.
Yeah, we have to add 4 to 3 kilometers. So it gives us the distance. It is 7 kilometers. And then they asked, what is the displacement? So we have to use that theorem and then we will find the answer. So we have to take AB square equals AC square equals AB square plus BC square. So we will get the final answer, which is 5 kilometers. So that is the shortest distance which is here, given here. It should be 5 meters. That is the displacement. Okay, did you understand that?
Yes, teacher.
Yes. Then I'm
Yes,
moving to
teacher.
next. Yes, okay. Now we are moving to next one. This is a running track, which is in a playground. Normally, we have seen that there are short distances running event like 50 meters, 100 meters. So in that way, in a big playground, they have just straight line like 200 meters, straight lines. Uh, yeah, it is not just 200 meters, but 50 meters like things we can take it as a straight line. But here, it is a 200-meter running track, but it is not a straight line. It has some circular shape like this. So when we consider about the distance here, it is 200 meters. That is the length of the running track. And if we have to take the displacement, we have to consider about both starting point and end point. Here, starting point is A, end point is B, and we are coming from here to here, from A to B. So we have to consider about the direction too. So the direction is 70-degree angle from north to the west here. This is the angle, 70 degrees. And the length of the path, the straight line length between this A and B is 160 meters. So we can answer the displacement is 160 meter in the direction of 70 degree from north to the west. So that is our complete answer. Okay.
Okay, teacher.
Yes. We are moving to next part. So I told you about the distance and displacement. While I am talking about that, I always saying that distance have a magnitude, displacement have a magnitude, but when we consider about both things, displacement is having a direction too. So distance doesn't have a specific direction. So when when there's a quantity, there are different physical quantities in our science lessons. We are learning about different things: area, length, force, and magnetic fields and energy. We are talking about these different quantities in our science lessons. So when we talk about this, all the quantities, we have two main groups depending on the presence of direction. Actually, we consider about the direction here. So we made a group as scalar quantity. They are having only a magnitude. They are having only a magnitude. They don't have this direction or this direction. There are some examples given here. You have to fill your, you have a space in your, you have a space in your tube to fill what are the scalar quantities and what are the vector quantities. So here, length, area, volume, speed, mass. When we consider about mass, it doesn't have a specific direction. We just tell this is having a 2 kilogram mass, and this is having this person is having a mass of 50 kilograms. So it doesn't have any direction. We are not telling this person have a mass in north direction, and that way we are not telling it. So, but when we consider about weight, we have to consider the direction. Weight is just in the downward direction due to the gravity of this earth. We are not telling a weight is just in upward direction. It is always to the downward direction. So mass doesn't have a direction, but weight has a direction. So in that way, length, area, when we consider about the area of this square, it doesn't have a direction, only a magnitude. We can tell that this is 2 meter in this side and 2 meter in this side. The area is 4 square meters, so that doesn't have a direction. But in this section, we have some vector quantities. So those are the scalar quantities which are only having a magnitude. And in vector quantities section, we have the quantities which are having both magnitude and direction. When we consider about displacement, we know that. And here it is not, it's wrong. It's a wrong thing. Oh, no. It's a direction. Actually, direction has the direction, we know that. But it should not be mentioned here. It's a mistake. And velocity, acceleration, force. When we are applying a force to a particular object, we are adding it a particular direction. When we want to pull a door, when we want to open a door, when we want to push a box, we are adding force, but especially in a particular direction. We are not adding force in opposite direction. We want to move that. We add a force in the same direction we want to move that. So they are having a direction. And magnetic field. We know that magnetic field, we have some experiences with magnets from our grade 6 too. So when we take some magnets, we know that this is having a good magnetic force than this one. Some are losing magnetic force due to some reasons. So they are having a particular magnitude. Some cannot attract large objects, but some magnets can attract large objects because they are having a high magnetic field. Then magnitude is there, and direction is also there. When two opposite poles meet together, they attract towards. But when two similar poles attract together, they are going away from each other like this. When we are taking n and n towards each other, they are not attracting. They are going away from each other like this. And those are the things you have to learn about the scalars and vectors. Hope you have understand this one. So I am moving to the next part of this lesson. So do you have a good idea about the distance and displacement?
Yes, teacher.
Yes. So now we are moving to the next part, that is speed and velocity. This is related to the distance and displacement. The reason is when we are talking about velocity, we have to think about the displacement. When we think about the speed, we have to think about the distance. Here it has change here. It should be in this direction. Okay, now it's fine. Uh, Velocity is the vector quantity that signifies the magnitude of the rate of change of position and also the direction. Now we know that change of position is the displacement and it is in a particular direction. So we can take a simpler definition for this velocity, that is rate of change of displacement. And if not, we can tell that displacement done at a unit time. We are talking about a second here. We can just tell 25 meters per second and 5 kilometers per an hour. That's a unit time. So maybe 1 hour or maybe 1 second. We are talking about a unit time, just a 1 unit of time, maybe an hour or maybe a second. So that is the unit time. The displacement done at this unit time is known as the velocity. So here we have this car here and its speed, sorry, its velocity here, it is mentioned as 25 meters per second. And especially it is mentioned that in the direction of north, that is moving in the north direction. But here speed is not like that, it's just normal. Here rate of the change of distance, we are just talking about the distance, like we are moving, we are going to the shop or we are going to the school. We are not moving in a straight line and we are just turning here and there. So rate of the change of distance. When we take like 10 seconds to move 5 meters once we are walking like that. So we can take 0.5 meters per second, that is our speed. It doesn't have a particular direction, and here it has a particular direction. This car is moving 25 meters in second in north direction. But this car is moving 25 meters per second, same magnitude, but there's no direction. It is just going on a particular path. Normally, we experience this speed. We can't think about this velocity because we are always turning here and there once we are driving a vehicle or once we are walking. This can be considered in a highway like straight line path. Okay, that is the thing. And then I'm moving in detail calculations, and we have to learn what are the units relevant to this speed here. So that is just a introduction like thing, and here this is the explanation. We get to know that rate of the change of distance is the speed. and distance traversed in a unit time is also can be considered as the speed. Here distance and unit time. If not, the rate of change. Whatever the word you can use, both are correct answers for the definition for speed. And here, it is given here that this car is moving in a distance of 1,500 meters. It has taken 20 seconds only. And then we have to find the speed. To find the speed, we want to take the distance traversed in a unit time. But we have given time as 20 seconds. So we have to find the distance which has moved in 1 second. So in order to find that, we have to find this total distance which is mentioned here by 20. It is here 100 and 20. Yeah. And here 1,500 divided by 20 seconds, our answer is 75 meters per second. That is the answer. May not be practicable or may be practicable. This is just a calculation. So within 1 second, it moves 75 meters, just like the very speed one. So that is the speed. Then here you can see the units for this speed is meters per second. We have to write it like this. To find this, we can just divide meters by second. So our unit for speed is meters per second. If not, we can have kilometers per hour in that way. That is another unit we are using in our day-to-day activities. We are not talking about meters per second once we are going to tell about the speed of a vehicle. We just use kilometers per hour. So here it is not miles. It should be kilometers. So the distance travel is 50 kilometers here. 150 kilometers has traveled within 3 hours. So his total movement for an hour is just 50 kilometers. So distance is the 50 kilometers per hour. Once we are dividing 150 by 3, it's the speed of that vehicle. And then there's another example. Distance divided by time, it gives us the speed. And here I have changed the unit kilometers per hour into meters per second. So kilometers, here it should be mentioned the first step here, 150 kilometers. In order to convert it into meters, we have to multiply it by 1,000. Multiply it by 1,000. And then we have to take 3 hours. 3 hours. Once we convert it into second, 1 hour has 60 minutes and 1 minute has 60 seconds. In that way, 3 into 60 and again into 60, multiply by 60. So our final calculation, it's here and our answer is 13.8 meters per second. Did you understand the way to convert that units. Did you get it? If not, you can tell me. I'll tell you it again. Is that fine, Timandi?
Yes, teacher.
Mhm. Uh, I forgot the name. Okay. Okay. Aaron, did you get it?
Yes, teacher.
Okay. If there's any difficulty, you can, in difficulty about this lesson, you can ask me the questions, okay?
Okay, teacher.
Okay. So I am moving to the next one. So we were talking about the speed. It's stuck. Wait a second. The presentation get stuck. Fine. Okay, we were discussing about the speed, that is the distance divided by time. Now we are moving to velocity. So that is simple. Distance, speed is about distance, velocity is about displacement. There's no change of unit, there's no change of magnitude. We have to consider only about the direction. There may be a particular magnitude, and we have to divide the total time which we have spent to traverse that displacement, and we will get our answer, that is the magnitude of the velocity, and together with that we have to mention what is the direction is. That is simple. That is the only thing we have to do here. So we know that velocity is the rate of change of displacement, and if not, the displacement done at a unit time. Both are correct. Then here, the first example which I was showing you earlier, and 20 meters per second. That is the velocity and in north direction. And here I have given the total distance he has traveled, that is 250 meters. And he has taken 60 seconds to traverse that. 60 seconds to go that, do that displacement. And we get the answer 25 meters per second as the magnitude of the velocity. So we can tell the complete answer for the velocity as to 25 meters per second to the north. That is our answer. So that is velocity. In the same way, we can consider this with kilometers per hour, that unit too. Maybe few kilometer distance in a particular path, we can divide it by the hours we have spent. Assume there is 150 kilometers from one town to another, and it takes 6 hours to traverse that distance, sorry, that displacement. But this is not practicable for the day-to-day activities, because we are just talking about displacement. We can't consider a straight line path in our practical life. So we can just take an example, but it is not practicable. 150 kilometers within 6 hours, maybe a big country with a big highway. So we have to divide that answer. So it's 20, here it's 25. Is that correct? Yeah. 25 kilometers per hour. So that is another question in different units. That is the way to find the velocity. But we have to mention the direction to, maybe in east or maybe in north or whatever we have to mention it to. And then after that speed and velocity section, I am moving to tell you something extra about this speed and velocity. Once we are talking about this speed and velocity, normally we have to consider about two things. Sometimes we are just maintaining particular velocity or particular speed throughout the entire time period. Here it may be 10 seconds. Within this whole 5 meters, we are maintaining 0.5 meters per second speed here. But this is not practicable for our day-to-day life, because once we are going somewhere, we have to slow the speed of our vehicle, or we have to slow the velocity of our vehicle, or we have to slow down our walking speed. We have to increase the speed of our walking speed. Or sometimes we are running. If we are going to exercises in the morning, sometimes we are walking, sometimes we are running. So if there's a particular path with a particular length, we can consider about a mean speed or a mean velocity. If it is a straight line path, we can consider about the mean velocity. If it is a circular path like a walking track, we are just mentioning about the speed. In that way, we can tell about constant or uniform speed or velocity. And if not, we have to tell about a mean or average velocity. If not, mean or average speed of a particular vehicle or something. Mostly we are talking about mean or average velocities and mean or average speeds in our daily activities. Otherwise, it's not difficult to maintain a constant or uniform velocity. But normally for a machine like thing, like a belt in a machine, they are moving in a particular constant speed. They are not slowing down, they are not running fast. But in a factory, we are looking at some machine. When we are looking at some machine, the belts in those machines are working in a constant speed. They are having a constant speed. So here we have to discuss at first constant or uniform speed. Why this is named as constant or uniform speed? Speed is the distance traveled in a unit time. So when we consider about a unit time here, if this 1 second, it is just 2 meters here. And when we think about the second, it is again 2 meters. And when we think about the third second, it is again 2 meters. In this way, in each and every second, this object is moving 2 meters. So we can see that this is constant. It is not changing. The distance traveled in a unit time is not changing. So here we can tell that distance travels at each second is same. So that is the constant or uniform speed. So we can just take the entire distance, or we can just take the distance he has traveled in a particular time interval, and we can divide it by that time interval. Here I have considered about this entire distance. No, sorry, it's not the entire distance. Hari. It has the, it has considered here that 6 meters. 6 meters. Only these 6 meters. The time which has spent is 3 seconds. So I have to divide the distance by time to find the speed. So my answer is 2 meters per second. Here we can see it is 2 meters. It is always 2 meters per 1 second. So is that clear?
Yes, teacher.
Yes. I am moving to constant or uniform velocity now. We know the difference between distance and displacement. So we can learn here the difference between speed and velocity when it is constant. We know the difference between speed and velocity, but here it is another term, constant or uniform velocity or constant or uniform distance. So here there's no difference, only difference is the direction. Displacement done at each second is same as in the distance. It is same. Both are having same calculations. But our answer changes as 2 meters per second to the east, 2 meters per second to the east. Same distances within each time interval, 2 meters, here 2 meters, same as the previous table, but only thing is it is moving in the direction of east. Is that clear? Hope it is clear to you. Then mean or average speed. Now the situation is different. Normally, when we are driving a vehicle, we have to slow it down. When a dog or someone cross the road suddenly, we have to stop the vehicle. And in the place where people are crossing the road, we have to stop or slow down the speed sometimes. And then in that way, we are changing our speed. Time to time, we are changing. Once the road is clear, we can go fast. So our speed is increasing. So in that way, you can see here, this is the time intervals. These are some time intervals. 1 second time interval is mentioned here, each and every place. And in this table, there's a difference in the distance traveled in each and every second. In first second, it is just 2 meters. In second 2, it's 2 meters, it's fine. And third meter, it's same. But what happened in the fourth second? It has traveled 4 meters. Did you get it?
Yes, teacher.
Yeah, we can see that earlier at the end of third second, it is having a distance only 6 meters. 6 meters විතරයි. But at the end of this next second, that is the fourth second, distance is 10 meters. So within this 1 second, only about 4 meters is traveling. And again, it is changing. In this way, we are having some experience about the change of the speed. In normally, when we are going a trip from here to Anuradhapura, we have some distance. Maybe I'll assume I can't remember the exact distance. I'll take it as no, it's not fine. Okay, 150 kilometers. Then I spend 5 hours. I spend 5 hours in that way. Here, in this path, I'm not maintaining a particular constant speed. I'm just slowing down. I am waiting somewhere to waiting somewhere to eat something or like that. Maybe we are slowing and we are accelerating our speed. So finally, we can tell that the speed we have traveled, that distance from here to Anuradhapura, is just 3 kilometers per hour. අපි ගිහින් තියෙන්නේ just only 30 kilometers per hour. So that is like this. So in this case, this car is moving 16 meters. 16 meters. In this way, it is moving 16 meters. It has spent 6 seconds here. Here I have to consider about the total distance from beginning to the end. From starting point to the end point, I have to consider about the total distance once we have to find the mean or average speed. Because there are different speeds. We have to take the mean or average value. We have to take the total distance like this, and we have to take the total time duration like this, and we have to divide them, and we can find the answer. It is 8 meters per second. Overall, this car is moving 8 meters per second as a whole. That means it is not moving 8 meters per second all the time. So it's wrong. This answer here, it is wrong. 6 meters, 16 divided by 6. It should be 2.5. Is that correct? No, it's not correct.
2.6.
Yeah, 2.66 like this. No. Yes. Yes, you're correct. So that is the, so there are sometimes these things, some mistakes. So that is the average speed. It is not just 2 meters per second. It is not just 4 meters per second. It's a in-between value. Not the highest speed he has traveled, not the lowest speed he has traveled. It's an in-between one. Like this. Did you understand that one? Timandi and Aaron?
Yes, teacher.
Yeah. Okay. So I am moving to the next one. That is mean or average velocity. In the same way, like mean or average speed, here also we have some time intervals and the distances travel at each and every second. They are not same. They are different. Here it is 2 meters all the time. But at the end, he has accelerated the vehicle. 4 meters per second here. 4 meters per second here. Within this first second, third second, first second, second second, third, fourth, fifth, sixth. Distances are different. So we have to consider about total distances, not the distances. I told that it's wrong. It's the displacement here in a straight line path in a particular direction. Here again I have mentioned it as the east. So displacement done at different time intervals are different. Each time interval it becomes different. So we have to consider total displacement. So straight line distance of the total path from beginning to the end and the total time we have spent to traverse that distance, and we have to divide them. Then here 18 meters divided by 6 seconds. So we will get the answer 3 meters per second. So it's an in-between value of both speeds. So we take the total displacement divided by total time. So you have to remember that here. And again, we have to mention the direction. Since this is the velocity and it's a vector quantity. But these are not vector quantities. Speed is a scalar quantity. We are telling just only the magnitude. But here it is a vector with a direction. And is that clear for you? Mean and constant velocities, speeds. Is that clear?
Teacher.
Yeah. Is that clear?
Yes, teacher.
Yeah. Timandi?
Yes, teacher.
Yeah. Okay. Now we have a question here. The variation of the displacement measured with respect to the starting point of a child riding a bicycle on a straight path during each 1 second time interval is shown in a table below, So we have given 1 second time intervals and also the displacement done. Here we can see that at the beginning, it is the starting point. If we consider this as the beginning, if we consider it as A, and he has traveled like this towards B. It's a straight line. And here, within first second, he is going 2 meters. In another second, again 2 meters. So that's why it has become 4. 2 and 2. And in next second also 2. Here also 2. In this way, he is moving like this for 1, 2, 3, 4. 4 seconds. But when he comes to this 8 meter displacement actually here, at that displacement, she or he has stopped. We can identify that from this table. In 5th second, displacement is 8. In 6th second, displacement is again 8. In 7th second, it's again 8. Again here at 8th second, it is again 8. Did you understand this one? Did you identify?
Yes, teacher.
Can you identify? Yeah, that's fine. Okay. So displacement is not changing. He is not moving. He is staying at rest in a particular point. And then what he has done is, in the 9th second, he has moved 4 meters. But this 4 meters, now my path is too long. So it's not good to be like that. We will clear these things. Here, if we take it as like this, 2 meters, again 2 meters, and again 2 meters, and again 2 meters from to B. So then in the 9th second, what he has done is he has come back 4 meters. And then again he has come back 4 meters to the starting point. We have to identify this. Here in 9-second displacement is 4 seconds. The 4 second means earlier he was in 8 meters and has rest there. And before that, in 3rd second, he was in 6 meter displacement. But now it is saying that displacement is 4 meters. The reason he has come back. And then here again 2 meters. So here it is 0. So once we have a table like this with zeros at the both points, we have to identify that displacement is 0. The reason is he has come to the starting point. Did you understand that?
Yes, teacher.
Yeah. Okay. Now, can you tell me what is the distance he has traveled? What is the total distance he has traveled here? Do you have an idea? It's the length of the path. Can you tell me? Now, I'll tell you again. He has moved from A to here at first, and then to here, and then to here to 6 meters, and to here 8 meters. And he has come back to 4 meters distance, and again another 4 meters. Now, what is the total distance he has traveled? එයා විතල තියෙන total distance එක කීයද? What is the total distance? Length of the all path he has traveled. Can you tell me? Or is it difficult to tell? Aaron and also Timandi, can you tell me? Is it difficult? Is it difficult for you? Shall I explain then? Can you hear me?
Okay, teacher.
Yeah. Okay, I'm going to explain it. So I think it should not be difficult for you because I have told you up to now what is the distance, what is the displacement is. So here, don't hesitate to answer once I'm asking a question, okay? So we can be very friendly, we can discuss the lesson. So don't be panic to answer. So it's really fine here. Then I'm going to discuss it here. So here he has moved at first 2 meters and then again 2 meters. Now it's total 4. Again 2, total is 6. Again 2, up to 8. Now total is 8. Now he has turned back and coming back 4 meters. So now 8 plus 4, now it's 12. Now again he is moving back 4 meters. So the total distance traveled is 16 meters. I know you would know these things because I discussed it earlier. That is the total distance. 16 meters. Yeah, ඇවිදලා තියෙන ඔක්කොම ටික. So here it should be 16, but the displacement, total displacement is 0. It is 0. It doesn't have a magnitude. It's just 0. இந்த පුතැන්ටම ආයෙ ඇවිල්ලා. Then here we can find the speed, but we can't find a velocity. That means the mean velocity. Mean velocity is the total displacement divided by total time. If we want to find the mean velocity here, it should be 0 meters divided by 10 seconds. 0 divided by 10 means 0 meters per second. එයා displace වෙලා නැහැ කොහෙටවත්. අන්තිමට ඉඳපු තැනමයි. So here, but once we are dividing this table into 3 parts, we can find at the beginning, he has moved with this velocity. At the middle part, he is not moving. His velocity is 0. He is at rest. And then at the end of the movement, he is moving fast. ඉස්සෙල්ලා දෙකෙන් දෙක within 1 second, he is moving 2 meters only. But at the end, what happened? When he coming back, he is moving 4 meters within 1 second. So he has moved very fast when he is coming back. So here we can find velocity is the displacement divided by time. We can take any point. We can take this, or we can take all the area. If we take this whole movement mentioned here, like this part, it is 8 meters. And the total time which has spent for this movement is 4 seconds. So 8 divided by 4, 2 meters per second. If not, we can just consider about 2 points here. මෙතන අපිට ගත්ත හැකි this 2-second time interval and this distance moved within that 2 seconds. So here our my calculation will be like this: 4 meters divided by 2 seconds. That's like it. So again, our answer is same, 2 meters per second. We can find and we can select any point only when the distance travel in each time interval is same. Only when it is same, we can find any point like this. So it will give us the same answer. And here, if we take the total distance, total displacement, the displacement done at here, it's 0. When we are staying at rest someplace, we are not displacing. අපි කොහෙටවත් යන්නේ නැහැ. ඉතින් it's 0. So it divided by the time interval, it means 0 again. So here the time interval from 4 to 9 seconds is 5 seconds, but the displacement is 0 meters. So we will get the answer 0 meters per second. Object is at rest. And then here at the later part of the moment, we can see, so here it's, I missed that. Give me a second. Here it should not be 5 because he has moved here. In that part, he has moved here 4 meters. So it should be 1, 2, 3, 4. 4 seconds. 4 seconds, yeah. නිකම්ම ඉඳලා. He is at rest. 4 seconds divided by, 0 meters divided by 4 seconds. Here, again, 1 second, 2 seconds. Within that 2 seconds, he has traveled 8 meters. 8 meters, that is the length of this path, the displacement from A to B. But the length he has traveled is 8 meters back again. So 8 meters divided by 4 seconds here. Again, it's just a here it should be 2 seconds. යට දෙකයි ගිහින් තියෙන්නේ. Seconds, 2 seconds only, 2 seconds. So here 8 meters has traversed within 2 seconds. So our answer is 4 meters per second. That is our velocity when coming back. Did you understand this? Up to now?
Yes, teacher.
Yeah, if there's any difficulty, you can ask. Aaron, what about your idea? Is that clear? Can you hear me? Is that clear? Oh my God, he has left. Maybe a signal problem or something. Maybe he is coming back. Since this is recording, it not be a problem to him. Okay, Timandi. So here, there's a message. Maybe it will be okay. Yeah. So here, Timandi, in this table, we have seen, we saw that there are 3 types of movement. So once we are given this kind of table, we have to explain the movement of that particular object, or here in this case, the movement of that child who is riding a bicycle. So we have to explain what he has done here. So in this case, we can start with this first part. That means in this first part, he is moving with a constant velocity of 2 meters per second. So we can tell that at the first 4 seconds, or at the until 4 seconds, we can tell at the first 4 seconds, if not until 4 seconds, he is moving at a constant velocity of 2 meters per second. And then he is at rest without moving for here 4 seconds. Then he is at rest without moving for 4 seconds. And then later I can tell, then at point B, he has turned back and come back to the starting point with a constant velocity of 4 meters per second. Timothy, did you get it?
Teacher.
Is that clear? Is it will it be easy? Will it be easy for you to describe this kind of a movement once we are given a table like this? Shall we try? Can you just tell how to tell that from starting point? You can start from here. It may be wrong or right. Don't think about that. You can just tell. Can you start from beginning? You can start with that word from beginning to the 4th second. In that way, can you tell me?
Yes, teacher.
Yeah, okay.
The object starts from
Rest. Yeah.
from rest to 4 seconds.
Yeah. Yeah, up to 4 seconds. It is moving at a constant velocity of
Displacement
constant velocity of 2 meters per
meter per second.
second. Yeah. Then what happened to him? Within next 4 seconds, එයා මොකද වෙලා තියෙන්නේ?
Object is at rest.
Rest, yes. And then
He starts the journey, and then
coming back.
4 meters
Yeah. In 44 meters per second.
per second.
Constant velocity to the start point.
Starting point.
Yeah. So his total displacement in 0 like this, and total distance is 16 meters. Good. You tried it well. Then our He's not coming. Okay, fine. Then to the next one. Let's get stuck. Give me a second. Yeah, okay. So we are moving to another part. So it's better to no, we will move with this acceleration and deceleration too. Then we can start in the next day with graphs. So I'm going to start the acceleration. So it's another thing we have to study in this lesson. So up to now we have studied distance and displacement and speed and velocity, and then constant speed and constant velocity, and then mean speed and mean velocity, the average. And then we are moving to discuss about the acceleration. So it is bind with the displacement. It is bind with the displacement because acceleration is the rate of the change of velocity. So velocity is a vector because displacement is a vector. Now acceleration become a vector. It's a vector quantity due to the reason that velocity is a vector. So in that way, you have to remember that this acceleration or this deceleration are vector quantities, because acceleration is the rate of the change of velocity. We are dividing velocity by time. Time is not a vector. It is not a vector because it doesn't have a direction. We are not telling that 6 seconds to this direction and 6 seconds to this direction. We are not telling it like that. So it's a scalar quantity. It doesn't have a direction, only a magnitude is present. So since this is a vector, acceleration is a vector. So here in this table, it is given that the way that the velocity has changed within time intervals. So here it is given as 1 second time interval and velocity change is given here. In first second, the velocity is 2 meters per second. But with the time, velocity is increasing. That means we are moving with a particular velocity and we are accelerating, accelerating, and accelerating. So in this way, it has become 2, 4, 6. In this way, 2 by 2, it is increasing. So we call it as a constant acceleration. In this lesson, in grade 10, we are just only talking about constant acceleration. Constant acceleration. Because there may be different amount of the increase of velocity sometimes. But we are not talking about that here. This is just a constant acceleration. So this is easy. No need to think about the mean or like thing. We have to just consider about the constant acceleration. So what we have to do here is, earlier in the velocity, you saw that we are taking the difference of the displacement. We are dividing, we are subtracting. අපි එක හිතලම ගන්නව නෙමෙයි, අඩු කරලා ගන්නෙ නැහැ, but we are just taking the difference. 8 minus 0, 8 minus 0. If we consider about this first 2 seconds only, 4 minus 0, that is displacement. In this way, 8 is the final displacement and 0 is the initial displacement. So we subtract, or we minus 0 from 8. So here too, we have to just consider about the difference, velocity difference here. So here final velocity is 12 meters per second and the initial velocity is 0 meters per second. So we are subtracting 12 minus 0 is, it is 12. So 12 meters per second divided by the time interval, total time interval which has spent in this speed, the velocity increment is just 6 seconds. We have to divide the difference of velocity by time. 12 divided by 6 is 2 meters per second. That is our answer. So mean velocity is it's not something which should be here. Is a mistake, which was mentioned here is a mistake. So here, they are not given the eraser. Okay, fine. So that is the acceleration. Did you understand that one? We have to reduce the initial value from the final value. Did you get it? Timandi, did you get it?
Yes, teacher.
Yeah. Are you tired now? Oh, you are not.
No, teacher.
Yeah, okay. So I'm moving to the next part. So in this kind of acceleration, we have to we are getting some questions like find the displacement in this kind of a graph, or maybe this is just a table. Sometimes we are getting graphs at the end of this lesson. There are some questions with graphs. We have to find the displacement done at this acceleration or different these velocities. We have to find the displacement he has done, or the displacement travels, the total displacement travels. So here there's a way to find it. What we have to do is, here we know that and we saw that the displacement is changing, sorry, not the displacement, the velocity is changing always. But we know that velocity, the equation for velocity is displacement. I'm just writing it because it takes time. Displacement divided by time. So in this equation, it is easy for us when we are given a particular velocity value and the time interval. A person may tell us like this: 2 meters per second is the velocity, and particular distance d, that distance has traveled within within 10 seconds. In this case, we can find the total distance because by doing a normal calculation, we can find this d. By using cross multiplication, we can multiply 2 by 10 and d by the 1 which is here. We will get d here and 2 into 10 in the other side. So that is 2 into 10 is 20 meters. The displacement it has done is 20 meters. So this is Okay for normal, just constant speed. It has a constant speed. But in this case, it doesn't have a constant speed. It is changing always. So we have to consider about a mean velocity. In this case, we can take it as 12 or 0 or 2. We know that the speed, the total speed should not be 0, because if it is 0, it is not moving. There's no movement. But it is not also 2, because if it is 2, it may not travel a long distance like that. But it also not just 12, because at the beginning it's just 2, 4, 6 like things. So here, what we have to do is take the mean velocity. To find that, we have to add initial velocity and final velocity together and divided by 2. That means 0 plus here 0 plus 12 divided by 6 ගන්නත් පුළුවන්. If sorry, 0 plus no, here it is, there's a question. What is the displacement within first 4 seconds? We should have to consider only about first 4 seconds. I took this total thing as that. So it is not the question. It is just about first 4 seconds. එහෙනම් අපිට හිතන්න තියෙන්නේ this time interval only. He has moved another 2 seconds. It's okay. But question asks us, what is the displacement done at first 4 seconds? So we have to find the mean velocity at that time and take the displacement done at that particular time interval with that mean velocity. So we have another word here now, mean velocity. It is not just the constant velocity, it's a mean velocity. Mean velocity equals displacement divided by time. In that way, here it should be a multiplication mark. And here, time multiplied by mean velocity gives us the displacement. So in this case, it is 4 seconds is the time interval. And we have find the mean velocity. It is 0 plus 8 divided by 2. And then the answer is 4 meters per second. So is that clear? Timandi?
Teacher.
Yeah. So now we have come to the deceleration. I'm going to stop the lesson today with this one, because we started later, and then we start late. So I'm going to continue with this part. I think this is clear for you. This is the rate of change of velocity, which is named as acceleration. And also deceleration is also a rate of change of velocity. But it is not the increase of velocity. It's a decrease of velocity. Velocity එක චුට්ට චුට්ට අඩු වෙනවා. Here it was increasing, the increase of velocity. Now here the situation is same. We have to minus the initial velocity from the final velocity. Final velocity here, it is 0. It should be remembered when we are doing something like that. Final velocity is 0. අන්තිමට නැවතිලා. So initial velocity is 12 here. 12 meters per second. So 0 minus 12 means minus 12 meters per second. That is the important thing which should be think about here. Here, since I have given that this is as deceleration, I have to put a minus mark here at first. Otherwise, I have to tell it as acceleration. This is the equation for acceleration. This is the normal thing. Acceleration is like this, but deceleration is the minus acceleration. Deceleration is the minus acceleration, like this. So we have to mention it at the beginning like this. So we have a minus mark here. So I correct it like it's better to correct it here. Okay, now it's fine. Here it should be, okay. Deceleration is minus acceleration. We have to start like this. If not, we have to start like acceleration equals final velocity minus initial velocity divided by time. And then we can find the answer at the end, and we can write then acceleration equals minus the answer. It's 2 meters per second like this, and we will get the answer at the end as 2 meters per square second. It should be square second again. Should be 2 here, meters per square second. Here you can see that the units of velocity is divided by the units of time. Then this is minus 1, minus square minus 1. Here it is seconds again. So our units of our answer is ms minus 2, because this is also coming to the top. ms minus 2, 2 meters per square second. That is the answer. So there's some mistake here. Don't misunderstand. Here you have to remember that initially we can tell just this equation which is mentioned here, and we can come up to here and just tell then deceleration is minus this answer. Then minus is, it become plus, and 2 meters per square second. Timandi, did you get it? Since it was somewhat messy here, did you get it?
Teacher.
Is that clear?
Yes, teacher.
Yeah, okay. So Timandi, we are going to stop here. It took some time because we were starting late. So shall we stop, and can you, before that, can you get that hard copy and answer all the things with
Okay, teacher. Do I have to get a printout or something, or shall I do it in a book?
No, you can't. I'm not giving the notes or anything like to write in the classroom. So you can just take a printout and you can put the answers in it and all the things. You can bind them as a file. You can collect all the tunes as a file. Is that fine? That is the way. Okay.
Okay, teacher.
Okay, then take the printout tomorrow, and together with that you have a worksheet. You can download it too.
Okay, teacher. Then how do I have to hand over it to you?
The thing you have to do it, the tute, you can do it since today you are not writing anything. you can just send me some photographs of the tute you have completed. So I will correct it for you. But later on in the classes, you can just write them in the classroom.
Okay, teacher. Then shall I WhatsApp you the tubes?
No, Timandi, you can upload it to the answer section. Today, it is not just the paper, since it is the tute, it's okay. But normally, you are not uploading the tutes, only the answer sheets. Only for today, you can put the answers in that tute because there are some spaces to fill. You can fill those spaces. I want to check whether they are correct or not.
Okay,
Normally, we
teacher.
are doing it in class, but only for today, you can do it like this. You can put the photographs, you can take the photographs and upload it. And also, you have a question number 3, question number 1, 2, 3, those things. You can complete those things and put the photographs of page number 1, 2, 3, 4 to the platform. Okay.
Okay, teacher.
Is there any difficulty? You can call this number. Give a call to this number. Can you write it down?
Yes, teacher. Tell.
076
Okay.
571
Yeah.
0930.
Okay, teacher.
Okay, you can get further assistance with the number. Okay, shall we stop? Good night.
Night, teacher. Thank you.
Welcome.